Thanks everybody for coming out and seeing me talk about exploit kits. A little bit about me. I am an amateur coffee roaster, a beer snob, and an occasional gamer. As far as my career goes, I've spent basically the entire time in security. The majority of that in SOCs. Started out as an analyst, working a 24/7 shift. I've been an analyst, lead analyst, engineer, policy, certification, accreditation. I like to say I've done everything but development, because that's just not me. As far as my research is concerned, most of it has been focused lately around exploit kits, and I've done some stuff about malware being delivered via email as well. Okay, so I like to kind of start with a baseline of what exploit kits are, how they operate, just to make sure everybody has a general idea. So an exploit kit is basically a web-based platform for compromise. As far as the components are concerned, there's some initial redirection that comes from stuff that I'll talk about, but that eventually leads to a gate. A gate is just a series of redirections with occasional probing of system before, if they find a vulnerability, deliver a landing page that's doing even further probing of the browser, doing things like finding out your OS, your browser version, the plugins you have installed, the versions of those plugins, and if they find a match, they're delivering an exploit page with some sort of payload. As far as the payloads are concerned, so malware downloaders they're pretty common. We see them a good portion of the time. Obviously, that's a first stage download. You get a malware downloader, there's a secondary payload associated with it. Historically, like with Angler, we see BDEP used to drop click fraud software quite a bit. Now they've kind of pivoted and are now delivering ransomware as a secondary payload. We do see stuff that I like to call the one-offs. Every once in a while you'll see things like Trojans pop up. A year and a half ago we saw some weird malware that was associated with it. It's not that prevalent, but what is prevalent is ransomware. Ransomware. I can't emphasize enough. Like 2/3 to 3/4 of the payloads now are ransomware. And it makes sense. Bad guys are out there to make money. Right now, how do you make money? Ransomware. So that's why they deliver it all the time. Let me take a step back and talk a little bit about the history of exploit kits. So I look at exploit kits largely as like an assembly line approach. So you have the domains you're going to use, the IPs associated with it. You kind of move down the line and pick out what exploits you want to use. Like I want to use these Flash exploits, this Silverlight exploit. You keep moving down the line. And then eventually you select a payload, hit go, and you're off and running. So if you go back, this is from like Ford in 1915. This is my analogy for where we were probably 10 years ago. Black Hole Exploit Kit was one of the first big, large, successful exploit kits. Anybody that worked in operations 5 or 10 years ago probably has many stories about mitigating a box that got popped by Black Hole and had zero access dropped on it. I can't tell you, there's probably a period of 6 months where I was mitigating at least one every single day. Look, these devices were really good at what they did. They compromised systems very effectively. But this is where we sit today. This is an assembly line from Mercedes-Benz from like a year or two ago. This is how I look at exploit kits now. They're doing far more sophisticated things. And you went from an industry that was making money, but doing things like dropping botnet clients. Now you're talking about $50, $100 million at stake. There is huge money behind these organizations, and it has really started to show. Seeing techniques and things like domain shadowing, which is compromising registrant accounts, hosting the malicious activity under subdomains for those legitimate domains. 302 cushioning, which is the use of HTTP 302s to use as another tier of redirection, another way for them to hide in the noise. And then even more so, seeing things like custom encrypted payloads, where the victim system is posting out data, that data is being used in a Diffie-Hellman encryption, and the payload is being custom encrypted to every single victim. This is not stuff that 5 or 10 years ago you ever would have thought would be associated with a threat like exploit kits. Okay, so this is kind of a high-level overview of how you get compromised. User browses to some website. Historically, it's very heavily either a compromised website, malicious ad. They go through a gate, they get served a landing page, browser gets probed, finds a vulnerability, exploits delivered, and a payload. But instead of just showing you a diagram, I'm going to run through a quick video, because I find that most people have never actually seen what it looks like for a user to get compromised. This is a newspaper from the United States, and when I was doing my research into Angler, I noticed that they were targeting obituaries specifically, which kind of makes sense in an evil genius kind of way. If you want to compromise people running a default web browser with old versions of Flash by targeting the elderly, you're going to increase your chances statistically significantly. But as you can see, some user goes, maybe they knew what Arlo Grabow here was looking up their obituary. In the back end, they are actually being fully compromised and ransomware is dropped on their system. As you can see, there is absolutely no indicator to the user. There's no windows that pop up. There's no things you have to click through. All it takes is literally just browsing to a web page to get compromised. All right, so that's my quick and dirty. This is what exploit kits are. Now the main topic, hunting. So the first thing I'll say about hunting exploit kits is this is a constant effort. You know, these kits are constantly evolving and changing. They are very, very good at making sure that they evade detection, you know, get delivered to as many users as possible, compromise as many systems as possible. You can get up to speed on kits if you know what you're doing, not too difficult, but staying up with how they change and evolve is the really, really challenging part. Okay, so one of the things that I like to focus on is not just the kits themselves, but how users are actually getting there. And this is a couple examples of some of the initial redirections and gates and stuff that I've seen. Start with this over here. That's a porn ad that was targeted specifically at Spanish-speaking users, as you can see by the Spanish word there. It's not uncommon for adult websites to be targeted by malicious ads and adversaries trying to compromise users. This is super effective. I've seen kind of a re-emergence of this in the last couple of months, and in a lot of ways it makes sense. You know, you don't really want to hit enterprise users if you're an exploit kit user. The reason being, you know that in an enterprise, you're likely to be dealing with a whole bunch of different layers of security. I mean, you're not just going to have the AV on the system, but you're going to have AV, you're going to have IDS, IPS, you're going to have web security, a whole bunch of different layers there. So by targeting adult sites, you're probably not going to hit very many enterprise users, at least you would hope not. And then here on the right is another example of a malicious ad I saw. This one's spoofing a gambling site. The ad itself was in German, which you cannot see at all. The one thing in particular that was interesting about this was the fact that it was redirecting to multiple different exploit kits. So one time I would interact with the ad, I would get Angler, and then interact with the same ad again, same sites, same domains. This time I would get Rig. This is a good example of either malvertising as a service, where you have an adversary or a group of adversaries that instead of focusing on delivering actual malicious content is more focused on just delivering traffic, so they could point wherever they see fit. Or you have an adversary that is using both Rig and Angler. Without any visibility, it's kind of hard to say. And then the bottom here, this is what you see very, very commonly in websites that are compromised. You'll see, I don't know, 1 or 50 of these iframes that are dropped throughout one page or many pages. In this particular case, it's pointing to a gate that again will point to an exploit kit. Now recently, this kind of took a pivot and a change that I hadn't seen in a while, or really ever. A couple of weeks ago, we started seeing this. This isn't obviously a spam message. The subject lines were all consistent. Your online order was successfully submitted, thank you. The things that they varied were the companies involved. So they used, if I remember correctly, about 900 different companies. Some of them really large, like AT&T, who's a telecommunications provider in the US. There was also Amazon on there, and then I saw a whole bunch of companies like this, which I don't know if they're real companies or not, but the point's the same. The text of the ad, or the email, was basically the same, and there was a single link to go to their site. Now, what was actually happening on the back end was I found this. And this is actually how I found this spam campaign. So I mentioned before, I spend time looking not just at the exploit kits, but how users are getting infected. And I started to see a couple of different web pages that were ending in order_details.html. One of the things I'll do is I'll try and figure out, well, how did the user get here? You know, it's not uncommon to see a compromised WordPress site delivering an exploit kit. What is unique, though, is having it in this big, giant, weird path. So what I ended up finding is only links to this. It's like the user just magically went to this one particular page. So I went ahead and looked in email to see if I could find the links, and sure enough, I found like 25 different sites that were involved and a couple of thousand email messages. So what happened to the user when they clicked the link? This is what is sitting on the page. It's just a title saying gathering order details, an image, and then an iframe. The image is this, which is kind of funny to me. I remember working with web-based vulnerabilities long ago, and when you're dealing with user-side stuff, you display a GIF like that to the user while in the background you're compromising the box. While that's running on the screen, this is what was happening in the background. GET request to a hard-coded IP. It was like a bunch of different subfolders. This one was Facebook API, which was pointing to Angler instance. The interesting stuff with this is the fact that it was running on port 8080. We do see exploit kits use non-standard ports occasionally, but it's not all that common. The other thing was, this was, I guess, so much volume that periodically the adversary would turn the gate down. The interesting thing is how they did it. A lot of times we just get 404s, they just take the page offline. They actually changed the link to point to like AT&T.com. So when a user would go to the page, they would be rendering AT&T.com like 3 feet to the left of their screen. Okay, so the stuff that I've found. I mentioned domain shadowing before, as well as 302 cushioning. This is kind of interesting. So this is the landing page for Angler specifically. And what's interesting about this is the quotes that they embedded in the page. So this is all quotes from Sense and Sensibility. No one seems to know why Sense and Sensibility, but the use of text in a landing page is actually quite smart for a couple of reasons. The first is, if for some reason something goes wrong and the user actually sees this page, which I have seen before in the past, they'll see some text, which, I mean, it looks a little weird, but it does not look anything like a garbage script page that you would get with most exploit kits. Additionally, if you're looking at something that's looking at heuristics or trying to do any type of machine learning, by inserting big blocks of text, it makes it look more like a normal web page than what you would get in normal malicious behavior. All right, so now on to the exploit kits themselves. I'll be talking about 3 today. So we have Angler, Rig, and Nuclear. And I'll be going into much more detail on a gate that I haven't talked about before as well. All right, let's start with the big boy. So Angler is the most sophisticated, most prevalent exploit kit I see out there by a very wide margin. The other kits are operating effectively, they're compromising users. They have nowhere near the scope and the prevalence that Angler does. This kit is everywhere. If you're browsing the internet in general, with the real explosion in malvertising and the amount of websites that I see compromised, you could literally be browsing a major pop culture site or looking at the web page of a shop down the street. You're highly likely to come in contact with this exploit kit one way or another. If you're running a patched OS and you don't take unnecessary risks, you're probably not going to ever know that it's there. So why is it so effective? This is my favorite graphic for this. So there's a couple of things, a busy graph, but the gray lines are when the good people at Adobe released a patch for Flash. The red lines are when Angler was seen actively exploiting it. In this case, this is from the 0 day from last January. That was before patch, obviously. But in general, this trend has continued to today. It's usually 2-3 days before Angler's actively exploiting a new vulnerability. That's a pretty short time window. The other thing that's important to call out is the blue dots. That is the instances that we saw particular versions of Flash being used. And the most concerning thing here is way over here on the right, you have June 1st. There were still a significant amount of people using a version of Flash that's vulnerable to 4 out of 5 of these vulnerabilities. This is exactly what exploit kit users prey upon. People still do not patch their OS. Now, as for the data itself, this whole project started for me at Black Hat last year. I was kind of sitting around talking with my colleagues, and I was thinking about kind of like a big data look at threats. I'd never really seen anyone do an attempt at a big data look at an exploit kit, and specifically Angler. So I'm lucky, I work at an organization with a lot of data. So I sat down and I was like, okay, let me think about this. When do I want to look for this activity? And I chose this month of July 2015 for a couple of reasons. The first being Angler, it periodically goes through changes. In July, it went through 2, I believe, then settled upon a final kind of version for their landing page for that particular iteration. And we did also have a couple of the hacking team 0 days get dropped. So if you're a user of Angler and you know you have unpatched vulnerabilities, you are going to be active. And that's exactly what I was hoping for. Before I get into that though, let me talk about what I was hunting. So what you see here is a list of Angler landing pages from during that period. And I started to notice patterns. You can see here, it's like an English word folder / and then there's a couple of different iterations. There's viewform.php, viewtopic.php, and search.php with a combination of keyword or keywords as the parameter attached to it. So that's where I started. Real basic. That's cut off here, but the URLs that end with one of those 3 things. I went that in, I kind of took a shot and said, hey, let me see what I get. Did not turn out too well for me. In general, with exploit kits, there's kind of 2 major approaches. There's those that work really hard to kind of hide in the noise and make their landing pages and exploit pages look a lot like normal web pages. And there's those that make their landing pages and exploit pages look really, really weird so that they stand out a lot. And they kind of switch back and forth. In this particular instance, Angler was trying to hide in the noise. They were doing a really good job. So I had to go back to the drawing board. And these are the things that I started to realize that I could easily filter out. Things like sites with no or bad web reputation. That was the only ones I was looking at. Now, I mentioned before, Angler uses domain shadowing, and all of them use domain shadowing now, pretty extensively. Now, there are going to be instances where you're dealing with an Angler instance that has a positive web reputation. But I wasn't trying to get a one-shot, get everything all at once. I was just trying to get on the right path. And by excluding all the stuff with positive web rep, I could eliminate a lot of noise. I also noticed that they don't use hosts that begin with www or forum. They do occasionally use forum in the path, but again, same thing. I'm trying to eliminate noise, not make sure I have everything in one shot. And then a couple other things, like for a landing page, your host that your URL is not going to be the same the host that your referrer is. And then I had to exclude a bunch of referrers that are super noisy. Getting rid of Google, Bing, Facebook. And again, some Angler actors are really good at breaking the referrer chain, but it's not 100%. And that's the whole point. I want to get rid of noise, not still have results with a bunch of noise added on top. So I tried all this and did it again. This time I was much, much, much more successful. I ended up with a lot, just a huge amount of data. So I started looking through this data, and there's so much stuff I don't really have time to talk about a lot of it, but one of the most interesting things was the IP space. So what I would see is things like this. On July 6th, they would be using 74, 63, 217, 217. And then on the 7th, they would be using .218. And then on the 8th, .219 and .220 would be active. And then on the 9th, .221 would be used. And I kept seeing this over and over again, where they were almost like walking through the address space. So I figured, hey, let's go see where these providers are. And this is a rudimentary graph of the providers that I saw. The two key ones here are Limestone Networks and Hetzner. That's largely, they were responsible for, I think, 3/4, 2/3 of the overall activity. So I went to them and said, look, I found all this bad stuff. It's bad. Here is all the evidence why it's bad. Are you willing to work with me? Luckily, Limestone Networks was really eager to actually work with us. And there's a couple of reasons for that. So I mentioned before, they were kind of walking the address space. It turns out what they were doing was buying a block of servers using fraudulent names, stolen credit cards, and then the company was losing thousands of dollars on credit card chargebacks. So because of that, and as well as the fact that it's a bunch of really, really bad activity, they were able to work with us and really provided us with a huge amount of very valuable information. This is a one-slide overview of what we saw. And basically what they did is they set up an enterprise service for compromise. I come from an operations background. If you're going to tell me I need to stand up a web server on the internet, there are a couple of things I'm going to say. The first is the server that's hosting the stuff that you are going to be posting does not need to be on the internet directly. Use some sort of proxying infrastructure, which is exactly what they did. They were proxying everything to a server in a completely different provider, different country. The next thing I'm going to say is I need health monitoring. And I'm not talking about ping checks. I need to know the website is up and active and operating as expected. That, again, is exactly what they did. They set up a status server and would do repeated GET requests for unique strings for each server, knowing that every single time it's going to return a 204. And the last thing I'm going to want is remote logging. I want to know what's going on. They also did that. They set up an alias on the proxy server that allowed the status server to basically go pull logs remotely. As far as the configuration, this is one of the sample Nginx configs. All of the servers were Linux boxes running Nginx. That's true of all of the exploit kits I've looked at so far. Over here you see the proxy configuration. They were running on port 81 for the proxy side. And then over here you have the unique string for the health monitoring for the 204, as well as the unique string for the alias for the logging itself. It's a pretty sophisticated, really well-designed enterprise platform for compromise. Now, why would they go through all this? Money. That is as simple as it gets. Over the course of a month, we saw about 150 proxy servers. We figured out that about 2/3 of the payloads were ransomware for that period. And from previous research, we see that like 10% of users are compromised by Angler. So we were seeing 90,000 IPs a day be served exploits, started doing some math. And then we looked at the percentages of users that would typically pay a ransom. We used a number here from US CERT, which was 2.9%. And then if you start doing some math, you realize that these guys are making an astronomical amount of money. About $3 million a month, or $30 million a year, even at 3% of the users paying the ransom. Even if you half that and say 1.5%, which means only that 3 out of every 200 victims actually pay, you're still making $15 million a year. It's really easy to understand why this is so prolific and so prevalent. There's just millions and millions of dollars at stake. So where are we today? The landing page URLs, they've kind of pivoted back the other way. So they went from hiding in the noise to really being unique. Now there's many, many, many different patterns out there. Some of them end in .html, .png. Other ones are just folders. Some of them just end with a hyphen in the middle. Some are using English words. Some are using random strings. It's a lot more focused on make the page as weird as possible, as unique as possible, as opposed to trying to make it look like something more common in the noise. What's funny is they actually went through a stage of going with another one of the looking like normal traffic stages where they were spoofing IP forum, if I remember correctly, is the software. And that lasted for maybe 2 weeks, and then they pivoted to this. So it's kind of that constant evolution again. All right, so that was Angler. Let me talk a little bit about Rig. Same type of process with Rig. So real quick on Rig. Rig is nowhere near the scale of something like Angler. But what it does do is it's still very successful at compromising users. For the same reasons that Angler is successful, Rig is successful as well. It's just not nearly as widespread. So I started with, in Rig's case, I started with the exploit page instead of the landing page. Here you can see what I was looking at. So what I found is a whole bunch of index.php files that were things like Flash or Silverlight. So I started hunting through the data again, and I ended up with something like this. So this is the IP addresses that I saw active. You can tell there's a stark difference. 147 servers in a month. This is 2 months of data here. The most servers I ever saw active in a day was 3. This is not nearly the scale of something like Angler, but it is still really, really good at compromising users. So I started looking at the provider, and come to find out, everything was hosted under a single provider for that entire 2 months. The provider was Eurobyte from Russia. What we did is, at that point, is I approached them much like I did with Limestone and Hetzner. And again, look, I'm not expecting all providers to work with me. I would love it if they did, but that's just not going to happen. But what I do expect you to do is say, yes, we understand that there's bad activity. We agree that you provided us logs that show that bad activity. We're going to remove the server, or at least acknowledge the fact that I sent you an abuse request. I sent them email after email after email, even reverting at one point to putting a couple sentences at the top saying, look, below you will find a translation attempt at this into Russian. I'm sure it's horrible, but at least it's something. Please contact me if you have any questions. I did that and just heard absolutely nothing, just deafening silence. So I started looking into the provider. They're not very big. They only had maybe a handful of Class C networks. What I did find is that there was really not very much good activity on there. Overwhelmingly, it was just bad stuff. And there was tons of exploit kit stuff, tons of various phishing and spam and everything else, with the exception of one. There was one provider one subnet that was hosting some sort of Russian payment system. And that had a positive web rep. The rest of the subnets were really, really bad from a web reputation perspective. So we took a different approach. You won't acknowledge anything, then we're not going to acknowledge you. So we blocked the entire address space, with the exception of the good subnet that was in there. And what happened next was pretty interesting. Within 72 hours, they were completely gone. Rig completely left the address space, left the provider as a whole, and moved to someplace new. I will talk about the new provider in a couple of minutes. Now let's change gears and switch over to Nuclear. So Nuclear is another really, really well-known, pretty popular, pretty large-scale exploit kit. Not quite the same level as what you would see with Angler. But the starting point with them was actually a little bit more difficult. What I ended up with was a bunch of .asp flash files. Again, tons and tons of noise, just so much noise. So I had to do just absurd amounts of filtering, and I ended up with just a search pattern that could just best be described as just nasty. It was ugly, it was horrible, but it worked, and that's exactly what I wanted. So what I ended up with was a list of IPs, and I did the same type of thing. I have this list of IPs. Well, it's not quite as nice as Angler. I don't have that walking of the address space that kind of led me in a solid direction, but there is some kind of subnet grouping there. Maybe I'll get lucky with the provider again. Turns out these exploit kit authors or users really like to stick at a provider and just stay there. So again, 2 months of activity, all hosted out of a single provider. This time it was DigitalOcean. DigitalOcean, again, provided them the information. They were super helpful, very responsive, worked with me a lot. One of the interesting things is the differences. So I mentioned before, Angler users would register like a big block of address space with stolen credit cards and kind of walk through the space as they went. What you saw with nuclear is that they would actually do a single user account for each individual server, and they would use a coupon code to buy that server. So they would buy a block of servers, but since they're using different addresses, different accounts every single time, the address space is just all over the place. One of the most interesting things that I found with nuclear was the fact that it was just absolutely a global threat. So you can see here, this is a map of all the cities that were involved. They ended up being like something like 10,000 cities. Now, I'll kind of walk through some of the comparisons to what I found with Angler as well to kind of draw those comparisons. But I mentioned in the beginning the ad that was targeting Spanish-speaking individuals. I found that particular ad generating 25,000 IPs of traffic from that ad to nuclear in a single day. And you can see the results. I mean, you have a lot of Spanish-speaking countries dominating this landscape. And when you start looking at it from a country perspective, it gets even more interesting. Again, Spain is one of the big countries, not surprising. I did also see a lot of German users as well. But what's interesting is you have Mexico and Argentina having largely the same amount of victims as the United States did. And the United States user set is far bigger than what you have out of these other countries. The other thing is just the huge variety of countries. I had 125 countries, and I saw countries that I never thought I would see. Things like I see the United Arab Emirates here. I saw Syria and Iran and Venezuela, and this threat was literally all over the world. To give you a comparison of how different that is, this was Angler activity from when we did our research. Almost 3/4 of the victims came from the United States and the UK alone. Additionally, there was only 12 countries total that were impacted. But you really can tell a stark difference in the two countries that are different, United States and the UK. Now, why would an adversary want to avoid those countries? The easy reason is just the amount of eyes that are on that traffic. You know, threat researchers are all over the world, but there are a whole lot of them looking at a lot of data that's focused heavily in the United States and the UK. By avoiding that address space largely, you're going to avoid maybe as much attention as you think you would get by attacking them. The other thing is they could be looking at targeting countries that may not have the same level of software that's installed. You know, it may not be as common to have, 2 or 3 different AV systems running on your home desktop outside of the US and the UK. Now, obviously, in the rest of Europe, that's pretty common, but you can see here there's a huge chunk of countries that are not necessarily in that place. Okay, so this is an Nginx config from one of the nuclear servers. One of the interesting things about this is the basic user agent blocking they were doing. There's a bunch of stuff up here, but you see some security software companies, some stuff that's crawling the internet. What you actually can't see here is they also blocked game consoles specifically. So I saw things like Nintendo, Xbox, and PlayStation specifically excluded from the infection vector, which makes sense, but you don't see this commonly. And the other thing is they were using proxy configuration much the same. However, they had far better OPSEC on the servers themselves. There was no logging. Like, they went out of their way to make sure that nothing was logged. There was no remote logging being done. They were passing the IP in the header of the true victim, but nothing was being logged off the system directly. They were, however, still doing health monitoring. So every 5 minutes, like clockwork, would see a GET request for test.x.test. Now, what was particularly interesting about this is kind of the circular logic that they're using. So you can see here, that's the actual proxy server. Exploit server. So they were sending a request from the exploit server to the proxy server that would proxy it back to the exploit server, which would then respond with a response to the proxy server that would go back to the exploit server. Kind of an interesting way to do it, largely just making sure that everything is living on one system. As far as the GET itself, every single time it was an octet stream with a whole bunch of X's in it. That's what was returned every single time. So they're still doing health monitoring, they're still doing that type of stuff, but it's a little less sophisticated and enterprise-like from what we saw from Angler. Okay, now on to the gate that I haven't talked about before. This is something that I called shadow gate. And again, a lot of this started from me looking at refers. This wasn't all that, wasn't that much volume, but every once in a while I would see this pop up in a refer chain, where I would see a shadow domain with a couple of subfolders or one subfolder, and then a JavaScript file being hosted that was redirecting to Angular. It wasn't a huge volume, but it was something that I found interesting enough that I started and was like, well, let me start digging into it. So I did the same type of thing. I started hunting it to see what I could find. This is my chart of the data. The amount of data that I found was absolutely staggering. Everything was focused in a couple of days here, like between the 10th and the 20th. But I ended up with, 900,000 rows of data. This was a really, really large scale campaign. What was so interesting about it was only active for very, very small amounts of time. So I had 900,000 rows of data here. I found 0.1% actually delivering an exploit kit. The rest of it would just return nothing. A 404, a blank page, just nothing there. That was actually quite interesting and unexpected. I mentioned before the shadow domains. There were, 50 that I found in the month or two I was looking at this, and they keep adding and removing as time goes on. It's pretty well spread out. None of them really take that much percentage. What was interesting though was the MO was very similar to what I've seen from domain shadowing. That is that all of these registrant accounts were registered by GoDaddy. It has nothing to do with GoDaddy at all, really, other than the fact that they're really good at what they do. So GoDaddy is the largest registrant by orders of magnitude over everyone else. So if I'm a bad guy and I'm going to set up a phishing campaign to gather credentials and I want to put all this infrastructure and effort into it, I'm going to hit a surface where I can get the most users. And that's exactly why you go to GoDaddy. What I found also was the same as before. You'd have a registrant account with, 4 or 5 domains. You would always find more than one of those domains being used. Not always 100% of them, but sometimes between 20 and 50%. One other thing that I found particularly interesting was despite having 900,000 rows of data, I only ended up with 12 different file names. Of all of that data, there was only 12 unique file names being served in total. The other thing that was interesting was the infrequency with the actual landing page itself. So I mentioned before that only 0.1% of victims were actually delivered to a landing page. What was interesting was the landing page itself would pivot all the time. So I rarely saw one particular infection chain lead to the same server or the same landing page. It was like they were pivoting and changing all the time. So this is my summary slide. 20 registrant accounts, multiple domains per account. The volume was just astronomical. This is the largest malvertising campaign I'd ever seen. To give you an example, I went to one single URL and was served 16 different malicious iframes through ads trying to get me into this infrastructure. Not a single one served data, but that's 16 times in going to one single web page that you're interacting with these systems. That's just a really high volume of data. As for the gate itself, it's not really anything new. Same thing as always, just served way off screen. What was interesting too was where this was being served. We saw a lot of car forums. There was a bunch of HR websites, some popular culture stuff. I didn't really find anything in like the Alexa Top 500, but I found plenty of examples in the Alexa Top 2000 that were redirecting through ads. But this was the most interesting thing that I found. While I was piling through these hundreds of thousands of rows of data, all of a sudden I started to notice that occasionally I would stumble across a Flash file or a Silverlight file, which was odd. I was like, this is a little bit peculiar. Let me dig into it a little bit further. What I actually found was systems that were pivoting from being a gate to hosting rig exploit kit. So this is one example here. On the 25th of March, we saw them serving the gate. On April 2nd, they had now switched to being a rig exploit kit server. Another example, this one is even a shorter window. On the 19th, we saw it delivering a gate, and on the 21st, it was then hosting rig exploit kit. It's a pretty quick turnaround and an odd coincidence, to say the least. But back to the IPs. So these are the list of IPs that I ended up with associated with the gate itself. Did the same type of thing, looking up, and luckily enough, they're all being hosted out of a single provider in Russia again. And I was like, that provider looks really, really familiar. It turns out that's the provider that was pivoted to when RIG moved away from the other Eurobyte provider that we saw before. I'm still trying to work with that provider to gather some information and let them know what's going on. There's more research on that to come. Again, this was far and away the largest malvertising campaign I've ever seen. And I found yet another link between Angler and RIG. I talked about at the very, very beginning that I saw an ad that was redirecting to both Angler and RIG instances. Again, points to either you have adversaries out there that are running both RIG and Angler, or there's some other type of link going on that we haven't been able to find yet. Okay, so in summary, exploit kits literally compromise anyone. That is one of the things that really got me into looking at exploit kits. I'm always interested by adversaries that do not care about their target and will literally hit anyone on the internet. The malvertising and compromised websites are just very, very large scale, happening, constantly driving traffic. But even that is continuing to evolve. As I walked through the spam example before, I expect to see more and more of that as time goes on, because it's just another way, like we see with ransomware, where you're getting users in as many different ways as you can. The parallels between them are obvious, because when you take a threat like exploit kits, you add a payload like ransomware, you make it so you can pay basically invisibly through Bitcoin, and you're maintaining your anonymity while you go. It's going to be a major challenge, and it's just going to get worse before it gets better. All right, I want to take a second to thank the providers that worked with me. Honestly, I do a lot of research, a lot of hunting, find a lot of really cool stuff, but without their help, I don't get that visibility into the back end that really helps expose not only what the bad guys are doing, but allows me to share that information with a wider audience. I want to force them to spend money to evolve and develop. I don't want them to just keep operating the way that they are. Speaking of which, if you are a provider or work for a provider, I really want to work with you. I am very happy to work with you, publicly or privately, it does not matter to me. We actually launched a project associated with our Angler research to specifically allow us to work directly with providers. Reach out to us, that's my Twitter handle. Feel free to reach out to me, tweet at me, DM me, whatever. There's a web page, there's our external email. We really want to work with providers. Providers are in a unique circumstance to be able to say, we see bad activity on our network, or we see bad activity on your network. We want to come work with you and help you get rid of the threat, and hopefully help expose what the bad guys are doing. Help us stop the threat altogether, not just shut down a server or two. One more thing, for those of you that are interested in hunting things like Angler, I'm going to throw out a couple of email addresses here for you to look at if you like hunting domains and stuff like that. So one of the interesting ones here is yingw90@yahoo.com. This particular host was a Angler, hosting Angler under their domains. They were hosting the majority, and still are, hosting them or owning the domains associated with the majority of BDEP-C2. Was able to pivot on the first name associated with it, find another host that's registering accounts, patrafamine44as@gmail.com. That particular one was not hosting Angler directly, but was hosting BDEP-C2 and was also tied into a bunch of other stuff. So I ended up stumbling upon the email address in some Angler redirection that I was looking at. I also found some domains associated with KZ and semi-Trojans. And then finally, we have here john.brugink@yahoo.co.uk. This particular host also very heavily involved with angler redirection and a couple of other threats that we've seen. One final one, and this is actually pretty recent. So this particular name and email address, mako@list.ru and mako.evgeny, has been absolutely prolific in registering and hosting angler activity. I talked about this. So angler disappeared for a couple of weeks at the beginning of the year. When they popped back up, this guy started registering like 30 or 40 domains a day. The majority of these 3,000 domains have been registered since the first of the year. Okay, so I have some time for questions.
All right, we have several questions. I'll start right here. Hi.
Hello.
Oof, this is loud. I've noticed, I've caught that you've mentioned Nginx, and I know it's faster than Apache would be, but how come that nobody's hosting from Apache or IIS even, or anything like that? How come always Nginx? Do you have anything on that?
I have no idea. It's just what we found on when we looked.
I've had another small one. Have you ever correlated anything in the obfuscation methods that they've used? Was there any evolving in there? Have you looked at the obfuscation and obfuscation actually of the just the downloaders?
Mm-hmm. We've done some research into that, but I don't really have anything offhand that I can talk about.
Thanks.
Yeah. Thank you.
Noticed they seem to prefer providers in the Netherlands and Russia. Thoughts on why?
So one of the things that you could look at is things like privacy. They tend to pick countries that have very strong privacy laws. And nothing wrong with privacy laws, but there are implications from their perspective that makes that type of activity very attractive for them.
Another question back here.
You mentioned the operator's OPSEC when you were talking about logline. I was wondering if you could just talk about the OPSEC that you saw in the other kits as well, briefly, if there's anything of note.
So the biggest thing with Angler was, since they were doing remote logging, they were maintaining a lot of logs on the systems themselves. So we're able to get a little more visibility into the activity that was going on. They did have some other things that were logging, like in the nuclear instance, they basically shut down every bit of logging on the system before they ever logged in. Like they didn't do anything bad until everything had stopped. Angler, not necessarily the same type of detail. They left a lot of logging on, they just may not have cared. The nuclear reactor was definitely very concerned about what particularly would be logged on the system.
More questions back there?
You mentioned how indiscriminate the campaign was. Did you see any attempt when fingerprinting of trying to avoid certain keyboard layouts like Cyrillic or Mandarin or anything like that?
No, I don't recall seeing any of that. It's possible that they're doing that stuff actually at a higher level. So I'm seeing more and more types of fingerprinting being pushed out to the gates to kind of drive down the amount of traffic that actually makes it through to the end system, to the actual landing page itself.
Oh, right here.
I'm curious, what else is getting exploited except Flash? Like Flash is kind of going away now. Is something else getting exploited by them?
So I've seen them actively using Silverlight. They've been doing that. Rig has actually added Silverlight as well. In the past, I've seen them exploit Internet Explorer vulnerabilities. That was actually one of the first places where the custom encryption with the Diffie-Hellman was seen, was associated with, it was from 2015, an IEE vulnerability in 2015. Those are the big ones that we see. Every once in a great while, we might see some Java pop up, but it's really not that common anymore.
I saw some of your notes at the end there where you were connecting different exploit kits based on certain things like email addresses. Do you have any thoughts around how accurate that is, or if they could be working together to mislead investigators?
It could be. It's hard to say. All that I can say for sure is that you have a bunch of registrant accounts that are creating domains for a whole bunch of different threats. That seems like a coincidence, little bit weird, but you know, that's all I can really say from that perspective. Yes.
Any more questions? So I have one. Bitcoins have the name that they are very anonymous, but they can very easily be tracked. Have you looked into tracking Bitcoin payments?
So you can track it to a certain extent. What becomes difficult is when they start using things like mixers and hitting multiple different tiers of mixers. Then it becomes very, very difficult to see where it comes in and then where it actually comes out. You can see the initial money coming in, but they're usually very, very smart. They're hitting, I don't know, 12 or 13 different wallets and then hitting a couple mixers along the way. It's really, really hard to say with certainty where you go from A to Z.
True, but you can make more realistic. You can judge more realistically what they're making, what kind of money they're making.
Yes. Very true.
Thank you very much for this excellent talk.
All right. Thanks a lot.